Okay, very good morning, everyone. Welcome to the location data space event. For the next 3 hours or so, we will be looking at how location data is being applied and being shared. And this is a part of a webinar series where we look at different domains that are part of the Gaia-X ecosystems, and we zoom in for a couple of hours and look at different use cases and applications of it. My name is Victor de Vries, and I'll just be giving a couple of housekeeping points and contextualizing this webinar. So just to run through the program very briefly, we will have a welcome introduction from Gaia-X CEO Ulrich Ahle, then Emmanuel Mondon, who is the co-lead of the Gaia-X location ecosystem, which we have organized this webinar together with the Gaia-X ASBL, the association here in Brussels. And he will set the scene of the context for a location ecosystem and location data being used. Then we will have a panel discussion where we will look at the different possibilities of using location data from different perspectives, from policy, from industry. And then we will have 3 use cases where we'll very much look at how value is being extracted from location data. And then we'll finally have a panel discussion on the horizontal applicability of location data. Then we'll wrap up with a couple of questions if there are any, and then we'll all get on our way. So just as a wider context, location ecosystem is one of the 16 ecosystems that Gaia-X has. So they have, the location ecosystem has been organizing this webinar together with Gaia-X, as I mentioned, but it is part of a wider set of ecosystems focusing on different domains that Gaia-X has. Then before we turn to Ulrich, just a final couple points of housekeeping, that this webinar is recorded, which will allow us to put this recording on the Gaia-X YouTube channel. So all the visual presentations and the speakers' interventions will be available there for you to see after the event. We kindly ask you to use the chat function for any questions that you might have during presentations. Actually, we highly encourage it. And please also, it would be very helpful if you could address your questions to speakers so that we know who to direct them to. And then if you also have any oral questions, we will take them if we have some time at the end of each panel. And we will also take them at the very end. So if you have any oral questions that you would like to address, we also welcome them, but we'll take them at the end of each panel at the end. So then I will invite Ulrich to share his screen and give the welcome and introduction.
Yeah, good morning, everyone. Victor, could you share? Because I have problems with my computer. I can't hear you, so I'm using the computer of Chris. Would it be possible for you, or?
Yeah, just... Sorry?
Would it be possible for you to share?
Yeah, I will open it.
That's perfect. Thank you. And while Victor is opening it, I would like to start this webinar with just one slide I'm using since years, and I've used it in hundreds of presentations. And the title and the headline is our new digital life will gravitate around data, around context information, around digital twins. And these are data describing what happens when, why, and especially where. So this geolocation of data describing what's happening is of utmost importance. And this is what this webinar is about location data, about geolocation. So where have data be created? And Antti, you don't see anything because it's not yet shared, I think. Victor, I sent the presentation.
I'm opening it now, 1 second.
Email. Yeah, so to all of you, you will see it in a second. And on the next page, I think you should be able to see the picture. Yeah. So again, our new digital life will gravitate around digital twin, around context information, describing what's going on, where, when, and why. And here the where is underlined. The where is describing the location where data have been created, where data are used. So the where, the location, is of utmost importance. On the next page, we see, if you go to the next page, please, Victor. Yeah, we see the investments done in data spaces, because the approach here of Gaia-X and all the family, all the community, all our partners, is to create data spaces operated on a federated cloud infrastructure according to German legislations, the Data Governance Act, the Data Act, the AI Act, are providing us the frame. And within this frame, a lot of investments are done into the creation of interoperable data spaces operated on a federated cloud infrastructure. And you see here a list we have started to put together. So it's not yet complete. And if you should have any additional investments you are aware of, which are not listed here on the different member states level. So you see here a lot of member states investing into data spaces, and highlighted in red also some investments, or especially some investments of the European Commission when it comes to the creation of what is called the high value data sets, and also the Destination Earth initiative. So in total, more than 3.5 billion euro are spent into the creation of interoperable data spaces. And again, the question, where have the data been created, is of utmost importance. On the next page, we will see the different, or we do see the different domains where data spaces are created. You see in-house, in industry, so in manufacturing, discrete manufacturing, in automotive, in process industry, but also in agriculture, in mobility, supporting the Green Deal, in public administration, in finance, and so on. And the principles are shown on the left side. So free flow of data across sectors and countries. For this, we need standards. That's what we are working on, to define and create the standards. Full respect of GDPR, to be able to also include personal data. And at the bottom right, we see this topic of high value data sets from the public sector. Means weather data, geospatial data, statistics, and so on. If you go to the next page, we see a definition of this high data value sets. So according to the directive on open data and the reuse of public sector information, high value set means data with the potential to generate significant socioeconomic or innovative services, benefit a high number of users, assist in generating revenues, and be combined with other data sets. Especially the last 2 points are very important. Generating revenues is the basis for really creating sustainable data spaces and for the creation of data models. And to be combined with other data sets, this is the major task of this undertaking of location-based data, because they are required to support other data spaces and to bring the answer to the question where into these data spaces. On the next page, sorry, we see these 4 projects which are funded within DG Connect, related to the Digital Europe program and providing high value data sets. You see the 4 names of the projects here. In total, 20 million of euro are put into these projects, and we will see more details on these projects during this webinar a bit later. And the next page is providing an overall architecture with base services, where Gaia-X Federation services play an important role, but also the overall trust framework of Gaia-X is playing an important role. Then we have different connectors to bring this data to the domain-specific data spaces, which I've mentioned already earlier. On the next page, there's another project, the Copernicus data space ecosystem, another 150 million euro to explore the Copernicus data space ecosystem. Another program of the European Union in cooperation with ESA and Copernicus. And then another one on the next page, the destination Earth system. I mentioned it before in the overview of the fundings, 240 million, which are spent here, which are planned to be spent here for the core service platform, for the data lake, and then for digital twins and the digital twin engine. And finally, on the last page, there is a procurement activity called Simple, also a project of DG Connect. And Simple has the main task in collaboration with the activities we are driving together with partners to create interoperable data spaces based on a federated cloud infrastructure. We came up with a set of building blocks, and a lot of building blocks are instantiated already. So you have open source software behind it. You can use them like Lego stones, but other building blocks are still white spots. And here, especially Simple Open has the task to fill these white spots. Then Simple Labs will provide a lab environment to implement all of that. And finally, Simple Life, which is the third part of the Simple product or project family, will create instances of European data spaces. And there you find also the destination Earth data space and the public procurement data space, so activities which are related to our activities here. Yeah, that's it from my side. I think this was the last page. If you go to the next one, it is simply thank you, wishing you a nice webinar here. And with this, I would like to hand over to Emmanuel. And sorry again for switching the device, but I think it went pretty well. Emmanuel, your turn.
Thank you, Ulrich. Thanks for your opening, and thanks for your support related to the location ecosystem. Very, very appreciated. I will have 5 minutes now to set up the scene. What does it mean, this location ecosystem? Where is it coming from? So I have a couple of slides as well. Let me share it. I will put in full presenter mode. Do you see my screen? Geoinformation data and space data?
Yes.
Yeah, okay. Yeah, so location data is any georeference data derived provided by a number of assets. Those assets could be in space, and that's the space data on the right side of this slide. And or this data could be derived from aero assets or even ground assets. We see here there is an overlap when we're speaking about geoinformation data and space data. So that's exactly why we decided to combine geoinformation and space into this location ecosystem. So whatever data having a georeference, being XY, XYZ, even XYZT, is part of this location ecosystem. And 2 years ago, we had two, within the Gaia-X ecosystems, we had two working groups. One dedicated to geoinformation and one dedicated to space. The geoinformation one was initiated by Germany, and then it went at the European level, while the space one was right from the beginning set up in November 2020, just before the first Gaia-X summit at the European level. And last year, we decided all together to merge those two into a location system. This location ecosystem is led by Christian Linder, who is working for the German Space Agency, and Antti Jakobsson, who is presenting in the next session, and myself are co-leading. So, in one page, what is the rationale of this location ecosystem? So the purpose is clear. It's a two-way bridge between the geospatial and space communities, and on one side, the digital community. So any stakeholder involved in digital activities through the data sharing and data economy activities, and on the other side, the different data spaces that were mentioned by Ulrich, in order to support the various use cases coming from these data spaces, which are embedding, leveraging georeference data. So we need to understand the needs and requirements from these data spaces related to the use of location data. We should support the various stakeholders coming from geospatial and space activities for contributing to these data spaces. And last but not least, and that's why we have in the next session a presentation from OGC, we should make sure that this interoperability layer, which was mentioned by Jordi, is leveraging, embedding all the specifications and standards which have been developed in the past 30 years. So from an objective point of view, raising awareness, making sure we are in direct liaison with the various member states which are implementing data sharing initiatives, and as well with the various data spaces. What are the key performance indicators for this location ecosystem? So we are willing to onboard the relevant stakeholders. As I said, on both sides, described in the purpose. And we are having a monthly meeting, and we are between 20 to 25 in each meeting across Europe. And as well, we like to keep close contact to the member states representative and the data and services business committee, DSBC, within Gaia-X, is helping us on that. We are having regular meetings. The last one was in last 2 weeks in Porto. From a deliverable point of view, organizing at least one workshop per year, we are very happy to have this location data space webinar today, and addressing the relevant events for promoting what we are doing. The last point is in this picture, describing the the aim of this location ecosystem based on digital infrastructure. And we have a number of platforms, infrastructure across Europe. We are leveraging those platforms and initiatives in order to gather location stakeholders willing to provide the information needed by one or another data spaces through an interoperability layer, and it was mentioned as well by Ulrich, simple, making sure this interoperability layer is considering what is existing already from a location perspective. I'm stopping here, and I will hand over to Victor for jumping into the next session. I will be pleased to moderate the next three sessions. I will stop sharing my screen here. The three sessions are gathering a number of panelists, and thanks to all for joining us and sharing your experience, expertise, and activities. We will not have question between the moderator, myself, and the panelists, because we'd like to enable any attendee to ask questions. So it will be an interactive section between the attendees, you, and the panelists. As Victor was mentioning, the Q&A will be at the end of each session, so each presenter has 10 minutes, except for Jordi, because Jordi has a hard stop in 30 minutes. So we will make a dedicated Q&A session for the first presentation made by Jordi. Victor, are you displaying the name and the presentation, or we move directly to the first one with Jordi?
No, Jordi can share his presentation if he has.
Yeah, okay. Jordi, I let you introduce yourself, and please go ahead. Thanks.
Okay, thank you very much. Good morning, everyone. Let me share the screen. Okay. Okay. Can you see it?
Yes, in full mode, in full screen.
Okay, thank you very much. So, good morning, everyone. My name is Jordi Escriu, and I'm working for the European Commission Joint Research Center in S.p.A. in Italy. I've been involved quite extensively during the past years in the definition and implementation of the S.p.A. directive. And now in the team, we are working towards this new paradigm of European data spaces, which is pushed by the Commission. And today I will try to provide our vision on the role of location and why a location data space is meaningful in this context. So let's go to it. So first of all, the policy context. Probably you have heard a lot about this policy context. So the context for developing these European data spaces for sharing data is provided by the European Strategy for Data, which has the goal to create a European single market for data. So it's kind of place where a user that needs for data, including location data, or other kinds of thematic data that could be available in that context, can go in the market and satisfy their needs, first of all, so finding the data, etc. So there are some problems that the current state of the art clearly left us. So the problems to be addressed is data availability, of course, interoperability, or also of vital importance, the quality of data, the governance of the infrastructures that we are using in order to share the data across data spaces, also the capacity, skills, data literacy of all the people interacting, cybersecurity issues, etc. So at the end, this European strategy for data is pushing for the development a common European data space and sectoral data spaces. So today I will not be boring you with the legal framework which is behind this European strategy for data. Also, it was mentioned in the beginning of this session with the Data Act, the Digital Markets Act, the Open Data Directive, with its implementing act on high-value data sets, and also the Data Act. But let's go to the topic which I think is more interesting today, which is the need for data spaces. So as you know, the current situation is that the data sharing is not, especially in cross-border context, is not really working well. So you can compare it with a brain with Alzheimer, which is a good example to illustrate this situation, where the flow of data is limited. So it's sector-oriented, with lack of trust and incentives. Fair practices are not assured. There is often low data interoperability, limited availability of data, and unclear licensing. Probably you also, if you attended the past webinar on 12th of June, these issues were also explained. And the fact of proposing these data spaces are searching the objective to correct these limitations. So the objective is to have a brain which is sane, and where we have all the sectors interconnected with mechanisms in order to push for data sharing, incentivizing it, and also providing elements giving trust for promoting this data sharing, with fair practices and rules in the market that address this data sharing, data sovereignty, pragmatic interoperability, which means not going beyond the primary objective in order to share the data, not overcomplicated in terms of standards as well, etc. So this means pragmatic. And have data available with clear licensing, and pushing for innovation methods in order to share the data. So it's interesting, I think, to look a bit to the definition of data spaces. So I took one of the most simple ones, in my view, which is the one provided in 2023 by the Data Spaces Supercenter, and they are describing a data space as a distributed system defined by a governance framework that enables secure and trustworthy data transactions. This is important to highlight, data transactions between participants, while supporting trust and data sovereignty. A data space is implemented by one or more infrastructures and enables one or more use cases. So here below you have the main elements that this definition highlights, but I would like to focus my attention also in these data transactions. This is probably a game changer towards compared with the past activities of data sharing we have been working on and experiencing during the past years, and also this trust and sovereignty, which aims to boost the data sharing across the sectors. So, first of all, I would like to say that the move to data spaces it's a matter of evolution. So we can see this as a technical evolution, as this article that the Joint Research Center provided time ago also highlighted. Where there is a need to connect to more data sources, think about volunteer geographic information, the Internet of Things, Earth observation platforms, data from the public sector, from the private sector, not only public sector, data from research, etc. Also applying novel architectures like APIs, data streaming, these data transactions. Why not to say the push for this Gaia-X ecosystem, etc. And we can see technological trends enablers, also organizational principles. And here I'm highlighting the need for co-designing this infrastructure and use sandboxing as a default. So it's a matter of testing things. If they are not working, provide a new solution for this data sharing, and continue this process of improvement in order to achieve a pragmatic interoperability, which is solving the problems from the users. So also more into the data space idea, this report from the European Joint Research Center is providing some ingredients in order which are currently available for developing data spaces, and these ingredients are mapped to the technical and non-technical requirements that are set by the European Strategy for Data and the staff working document on data spaces. So it's important that we have all the ingredients there, and let's go to this topic today about the location data space. So do we need one location data space? So this is a very good question. So as you can see in this slide, European Commission started this outline of different sectors, which is limited, let's say, health, industrial, productive, agriculture, finance, mobility, environment, energy, public administration, and skills. But we cannot see here where location is placed, probably because it's in everywhere. And also was mentioned at the beginning of the session that it's important, these high-value datasets from the public sector in order to feed these sectors, these data space sectors. But apart from this initial set of data spaces, sectoral data spaces, there is the possibility to develop further data spaces that could be, for example, location data, but any others. And why we need a location data space? So it's a matter of exploring interoperability and synergies between European location data providers. So first of all, the idea would be to establish a location data market. So all the organizations that are positioned in the market for geoinformation may decide to work together in order to share their data for pan-European purposes. And this market would be useful to identify, understand, and satisfy this pan-European location reference data demands. Also, good serve interpretable reference data from these providers beyond national borders. So we are quite used to only share our data in the let's say in the market we know, which is the national, the most approximate market we know. But there is also this need for cross-border pan-European needs. And also drive innovation by exploring new location data interoperability approaches and services for their possible reuse in common European data spaces. So at the end, allocation data space is needed if these organizations, these data providers, etc., all the interested parties which play a role in the geoinformation market see a future on that. And it's a way to build our own business, and exploring how location data organizations should be interacting with it in this concept of data economy. So the European Commission is really interested to push this data exchange between parties in order to push for businesses, for increasing the value of data economy and push for societal benefits derived from that. So here, in order to build this new future, these organizations from the geoinformation market could build on the extensive experience from they have from the past activities we have been working on during the past years, and it's an opportunity for outlining the next generation of location data services and user engagement. And I stress here the user engagement because many organizations were used to only push their data in the market without really considering the needs. So it's important to work in this mechanism in the market that let the users say, okay, I have this need and I have no data. What can I do? Who can help me in order to provide, satisfy this demand? So, and I would say also that it's important that these infrastructures, these new systems, transactional systems, are not only considered to solve cross-border issues, but also national needs. So the most important thing is that the system is used, and the best way for these systems to be used is to make it also meaningful for our daily market, which is more on the national level. So this is crucial in my opinion. And how more in a more technical context, how these data space approaches for location data could be tested. So it's a matter of exploring opportunities and also in the context of these 3 bullets I provided in the past workshop on the 12th of June. So we have to move from a supply-driven approach towards a demand-driven location data market. Also, we have to incentivize location data sharing and use by building trust and balance provide a balance between data centralization versus decentralization. So on the first topic, this demand-driven location data market, we need to develop a location data market while continue providing high-value datasets to these predefined common European data spaces, these sectoral data spaces we show at the beginning. But we have the opportunity to also explore this location data space and try to develop it in this sandboxing approach that we were commented at the beginning. And for this is super important to gather user needs for location data and cover them. So think about the mechanisms in order to capture these requirements with data supply, with potential data intermediaries and services, so that we go from putting the mission first and not the data supply first. Second, how to incentivize location, data sharing and use. So here I would say that it would be wise to combine authoritative data and citizen-generated data, but also other external resources or sources of information. And for the third bullet, this balance between data centralization and decentralization. This is related to what I said in some slides previously. It's important to focus that on the idea that a data space is conceived as a transactional infrastructure, federated transactional infrastructure. So probably we have to explore technical means in order to move from this traditional data service architecture that we are quite used to propose and use for within the spatial data infrastructure context. And moving towards an hybrid model. And this hybrid model would be including these transactional data exchanges where the traditional way of sharing data is not useful, not pragmatic, etc. So better to give the user the possibility to play with the data in their environment, and this could be performed through these transactions. And this is also related to the need to explore the adequacy of current APIs and their potential evolution in the future. So the high-value datasets implementing act is putting the requirement to provide data through APIs, but obviously the technical means to share the data are evolving. We have to cover the needs for data spaces, and nobody has tell us that the current APIs we have at the moment, I'm thinking about the standards and that we have in this area, nobody tell us that these APIs are sufficient in order to cover this need. So probably when moving to this transactional context, we will discover that maybe there are functionalities in the APIs that are not sufficient, that and there is a room for evolution. So with this, I want to thank you for your attention, and I stop sharing and waiting for your comments, if any.
Thank you.
Thank you very much.
Victor, I don't see any question.
Yeah, we do have a hand raised though from Oje Ludovic.
Okay.
So perhaps Oje, if you would like to share your question or comment.
Sorry, just a technical issue here. Can you hear me?
We hear you well.
I just wonder, how are we moving forward on those topics? I'm sorry to ask this question at this level, just I'm quite new to this, but by working on this kind of topic, I just wonder how to make it happen. When we say we have a landscape of technological bricks, how do we move forward?
Mm-hmm. So, very good question. This is probably the most or one of the most complex issues now. It's from where to start. No, so currently the European Commission has provided this concept of data spaces, and the way of pushing it has been to use what is called coordinated and support actions, which are really funding mechanisms in order to start working with this. The first supporting and this CSA coordinated and supporting actions from the Commission have been developed to the projects that, for example, the Data Spaces Support Center, which is the central coordinator for data spaces. This is a coordinated and support action. Also in the context of environment, and I'm just moving to the sectors, to the different sectors. For example, in the environmental sector, the great project. All these projects have been the role to start with this conceptualization, thinking about the use cases behind the data spaces. And now we are facing the change to other kind of coordination and support actions, which are aimed to start with implementation. And for example, one of these actions is the one that was also mentioned before, in order to push for this simple system, in order to facilitate the exchange of data in data spaces and between data spaces. And of course, all the actions to develop specific data spaces should be considering the opportunity to apply for these funding actions in order to somehow fund partially this development of new data spaces, that could be the location data space. So the idea is to find the budget in order to support the implementation of these initial data spaces.
Okay, thank you. I'm just sharing a post in relation with the topic for references.
Thanks.
Thank you.
Thanks, Ludovic. Jordi, conscious about your timing, I let you log out and shift to your next meeting. Thanks a lot for your presentation, which is giving us the big picture related to both research and policy. And as this panel is about multiple perspectives from research, policy, users, and industry, the next presenter is Antti Jakobsson. Antti is working for the Finnish survey and is managing the Location Innovation Hub, which Antti will introduce to you. Antti, the floor is yours.
Thank you, Emmanuel. Basically, what I'm trying to do in this 10 minutes time is to kind of convince you that there is a need for location data space, and that is something that we have been trying to think hard within the previous projects and also within the Location Innovation Hub. I hope that you can see my screen.
Not in full screen.
Not in full screen. Okay, let me try it. Change it.
In fact, you should share your screen, then put it in full screen.
Yeah, I will try to share my screen. So maybe now.
Yes, perfect. Thanks.
Okay,
Antti.
excellent. So basically, I will start with the location innovation hub and what we are trying to do with that. So we started last year. It's one of the European digital innovation hubs that are now established in Europe. There's about 151 of them, and we are one of them in Finland. There's 4 in Finland, and basically we are about the only center of excellence for location data among these 151 EDIs in Europe. And of course, the EDIs are trying to kind of help businesses, but also some EDIs are helping public sector to kind of work on digitalization, mostly on AI, HPC, and cybersecurity, and those are also our targets. But basically, we also set up a target to work totally on location data, and one of the targets that we are kind of trying to do is this interoperability of location and other data. And here we can see that there's a direct link to data spaces. And the other targets that I'm not going to address today is that we are working on seamless indoor-outdoor navigation and precise positioning, which are very also interesting parts, but not our my talk about today. We have a quite big partnerships for the 2 partners. I guess we are. I think we are one of the EDIs that have most partners with us, and of course that is a challenge sometimes. But also I think it's an asset for us that we have a lot of knowledge to share with our clients, and about 250 individual clients. That is our target in this 3 years time, and we have about reached 100 clients today. And one of the things that we are kind of trying to do is that we provide access to European national data and test infrastructure on that. And for that, we were lucky to have the previous project GeoE3 that provided the location Europe.eu as a test infrastructure. And today I'm going to share you our experience on what we are doing with the location Europe.eu. So if I start, why location data space? Obviously, there's a need for accessing reference data from European countries, and I here mean also this reference data kind of covers the high value data sets. So it's not only this kind of traditional geo information data, but also, for example, climate data and statistical data, etc. What is, I think, it's rather clear is that if we are looking the national infrastructures, they are not necessarily focusing on the interoperability at the country's level or different countries' level. So there's a need to do something at the national level when you are combining regional data, but also at the European level if you're combining this kind of national level. That is our experience working with this kind of data coming from, for example, from the meteorological institutes or mapping agencies, national mapping and cadastral agencies. So something has to be on top of that. And then, of course, if we think about the existing initiatives on the data spaces at the European level, if they would be starting to do this connection on for the national sources for high value data sets for each data space, that would be rather complicated, and they would also have to solve this interoperability issues many times. And also we can see that there's no solution at the moment how to deal with location data fully within the EU data spaces. So that is something that we would like to also address today, and of course with our experience. So those are the kind of arguments why we need this kind of location data space. So basically, we have created this Location Europe platform as let's say I would call it as a pre-location data space. And I put some of these things that we have been working on and try to map them on how they're related to data space value positions. So, for example, we have been doing a lot with data interoperability and data exchange. So basically, we are now able to show how this kind of, let's say, coming to be a little bit legacy type of mapping services like web feature services, web coverage services, and web map services, how they can be connected as an OGC API. So that is something that we have proved that is possible. We have also provided a model how we can publish this as an OGC API, one API for data exchange. We have been working on the data interoperability and data models, so using the inspired schemas, but also national schemas can be used. We have been working on the data quality provision, automated evaluation and dashboard. That is something that I think is currently missing in most of the initiatives that we can see from the data spaces area. And that is something that I think should be let's say, started to implement. Also, we work on this kind of data integration from multiple sources. So that is something that in most use cases needed. So something like that has to be done at the European level. We have been working on the interoperability assessment based on the European interoperability framework and FAIR. That is something that we can show, providing support for processing capabilities with HPC. So we are running this environment now within the CSC, which is one of the European HPC centers. And also we have been trying to work on the security part, providing the API key for accessing and basically also related to how this metadata is solved. So we have certain, let's say, certain assets that we can show that these are things that are working. Of course, there are certain things that has to be developed further in order to, let's say, call it as a location data space, really. Then I've a few slides on what we can show today. So an example here is the buildings 3D, and I think that's one of the complicated examples related to, let's say, digital twins, how you can actually connect these kind of 3D building type of data from different countries, and this map shows the availability from various countries that we can provide today. And if we basically start zooming, we actually also use the OpenStreetMap in the viewing possibility. So we can combine also this kind of global assets to this. And when we zoom in, we start to see the national assets and national buildings, and basically when you click one, you can also see that we have linked certain climate attributes to a building, like forecast temperature, wind speed, and sunshine hours. So these are related to the use cases that we have been working on, for example, solar energy potential and also the building energy efficiency of the buildings. And finally, you can change your view to show 3D view. So we have also roads there, the terrain models and climate information, but this is not limited to basically these kind of data sets, but it shows that this can be done. So that is a kind of proof of concept that we provide. Then we have been thinking about the location data space for Europe. We have created the project concept. Basically, we need to, from the technical aspect, we need to work on this general component for data spaces. We need to work on the business case, and we have kind of identified these kind of commercial enablers that would be in the end working and providing this this kind of information to the clients. And then, of course, the use cases, as Jordi said, is that they are very important aspect in order to go forward. I'm not going to go too deep on this today, but we have certain information available on this one as well. Basically, I think one of the biggest challenges today is that there is no clear understanding how this interoperability can be done. And basically, we have provided this Location Innovation Academy together with OGC, and we are running that under the Location Innovation Hub, and OGC is also participating in this and providing the current understanding how this interoperability can be done. So I would strongly recommend you to go there and have a look on the courses. And I put basically 3 examples of what is the most popular videos inside the academy. There's a strong interest on the OGC API features, OGC APIs, and using the, for example, what we are using in our solution is this AdviceGEO API in the implementation. We also strongly recommend that if you are a data provider, please consider joining us. And I put the link of the core data provider network there that we are running. There's already a number of European partners like Eurogeographics, EuroSTR that have joined, a number of NMCAs from the countries that have joined. But it's an open network that basically, if you are a private data provider, you can join as well. And basically, if you want to test our implementation, test our API, so you can do it for free. It doesn't require any money, but you have to register for getting the API key. Finally, in the end, I want to say that we are also now going to be launching this Location Finland, and this will be launched this autumn. We want to showcase and test, provide this kind of test before invest type of services targeted to Finnish audience, Finnish ecosystems. The idea is to start on the built environment, bioeconomy. We will be providing urban test areas. We have also other test areas like Agri and drones that will be visible. So it's trying to address these issues that actually Jordi raised, where we have to kind of link very new type of information together with this kind of reference information, and we will start with this Location Finland approach. And finally, I want to advertise that we will be running this GeoAI and bioeconomy hybrid event in the coming Schluss. You might know that it's one of the biggest startup events in the world. And together with them as an official side event, we will be providing this event starting with the GeoAI and bioeconomy, but we will follow that together with Netherlands and UK, and we try to kind of provide the state of the art, how the GeoAI and GeoAI and location and AI is kind of evolving. And that is something that also Jordi mentioned that is very important. I think Ulrich also mentioned that in his presentation. So that's the end. Sorry, I guess I overstated 3 minutes.
Thanks, Antti. Thanks a lot. I don't see any question in the Q&A panel. Is there any question from the audience? Feel free to raise your hand, and Victor will allow you to speak. No question? No. So I suggest to move on to Piotr. Open Geospatial Consortium was mentioned several times. Interoperability is key. Within stakeholders for a given data space and across data spaces. So Piotr, how much spatial is data space? Interesting questions. The floor is yours.
Yeah, that was the question that was raised by our friends and members, and it's not answered probably. So the question was how much requirements of the data spaces should impact the should impact the geospatial community, and vice versa, how much can be used from the geospatial or spatial community in the data spaces. So I'm not sure if I will answer that. Hopefully the whole discussion will do. And yeah, I'm representing the Open Geospatial Consortium, the Collaborative Solution and Innovation Program, especially in Europe. And we'll go through several of these, I guess, questions and issues we have. But first, yes, the OGC, the Open Geospatial Consortium, is this non-for-profit associations with clear mission. So the community is interested in the location information and still making it fair. It's like a moving target because we have many challenges, but it's good progress also proven in this environment. And how do we do this kind of combination of this collaborative and agile process when we are testing different approaches and experimenting with solutions, and then on the other hand, community consensus building, which leads to standardization and a good balance between this state-of-the-art practices and fit for purpose for the cases we are dealing with. Because the location is everywhere, maybe not everywhere, but many scenarios we see that was already mentioned. The location component is actually kind of key aspect. The whole community is naturally dealing with this several trends. One is naturally more and more data, but also more requirements on the data and more requirements related to data quality. You say trust and sovereignty, but that's all about the quality also of the data provision and the data itself. And naturally, the impact of the advancement in the computer science and modeling. So we have new solutions that are providing new infrastructure, but also new analytical tools which are producing the data. And then we have two challenges, which are the data input-output must be well proved and governed. And that was done for the last 30 years of the community, thanks to the members which are contributing to this effort in any possible way, I guess. Taking part in this work hugely contribute to our outcomes, but also supporting us from the organization and say financial perspective, because that needs this combination of collaborative knowledge, which is supposed to be added value to everybody, but also to enable and to unlock the value of the data itself, which is kind of tricky because it's also the balance between the value for the members and the community itself, which are the public and private organizations, the research organizations, and naturally everybody has different interests. And the balance between the value of the data providers, service providers, which are clearly monetizing that, and the others who are working for the general good. Everybody's working for the general good, but some have these priorities stated in the missions as well, which is also quite tricky. But the output is quite significant. The standards are open. The work is open and transparent. Kind of trustful way of going to the targets we have, that we can prove that it's really based on the good knowledge and good work being done, and also best practices and proof of concept, which should contribute to this and the other data spaces where we have discussion about the practical examples and really proving that it's working together. And in practice, what we have on the board for the moment is naturally this multi-source integration. And we were talking about the location data spaces. The urban environment is like natural fit for that, because that's all related to your local space. And that's not only about, if we're talking about digital twin of the urban environment, we are talking about the traffic management, planning of the infrastructure, the buildings, but also about the environment. So if in the future there will be the use case with the autonomous vehicles, they need to be aware of all of the conditions that are around. And also for the quality of our life, meaning that the environmental monitoring needs to be combined with this urban data, and then you have clear interest in your local space, but you are using actually the global data as well. And the global aspect is naturally visible in this digital twins effort, because they are kind of overarching and meant to be global, the digital twin of the Earth. Up to now, they are actually quite well grounded on the UGC standards, I must say. Naturally, there are some gaps which needs to be filled, and there are some various activities to do that. But we are also looking in this two perspectives, like the global one and the local, where we have the project like Iliad, which is simply solving the issues of the real life and real business. Connected to energy sector, connected to the aquaculture, harbors, and all of these aspects require really precise and local information, which is combined with this global information. But the local data is naturally different from the global one, and this is solved already by this community with this high resolution and well coordinated data. Because we have two dimensions. One is the data sources, and the other one is the data levels, or data decision ready level, which are coming from this raw data to really services, decision making support services. But the common point is, again, the location. So we cannot talk about this, we cannot use this data if we don't have this location ingredient. The data is useless simply if we don't have well positioned and fit for purpose resolution and quality. So what you see is also looking at this bottleneck between the impact that can be done with the data and the huge amount of the data that's available and that's growing, as mentioned already several times. And the bottleneck is naturally the way we are reusing the data and reusing the services. And here the effort is like twofold. One is the standards needs to be well defined and granular, and we need to make sure that the client applications are aware of what's out there and what services they can use technically. But then what information is available on the services is the other part. So therefore, we need to ensure that the standards we are developing are well fitted for reusing in these different domains, meaning supporting different vocabularies, different conceptual models of the domains. And thanks to this collaboration between the actors and stakeholders of the domains, we can prove it quite well. And I think this is also the case of the data spaces, like Jordi mentioned. There's no one proved way of doing the integration of the location in the data spaces, but there are some, and I think that we should leverage those and really find a way to move forward, because we cannot do it alone. We need to do it together. That's, as mentioned, quite fragile balance, and it's also not so hard to go to the dead end of this development and find the place that we cannot really speak to the other data spaces if we developed it on our own. So we need this even cross CSA actions that really leverage the good solutions and find and show the way for the others, but also solve the issues we have in this cross-sectoral data spaces integration. And that is being done partly also bottom up. There was quite a meaningful effort from the CS actions that were recommending the standards and already providing some existing solutions and identifying the gaps and the roadmap of development of this work. There were work like ISO task force, which provided the contribution to the data spaces report, which simply identify which standards are fitting which building blocks in the data spaces definition. And then we go to the application, which seems to require even more fine-grained definition of these building blocks. And therefore, you have the system level integration, which require good proof that the tools which are implementing the standards are also interoperable, and they are interoperable with the whole ecosystem, meaning that they can be combined with these different aspects, because the geospatial standards are not solving all of the issues naturally of the data spaces. They need to be well fitted into this whole ecosystem. And that's the demand that we receive from the community also, that we need the good practices of doing that. We need to combine this knowledge. There were even requests to run some test beds, pilots, code sprint, whatever that is really tackling these issues in the really foot on the ground and providing development advancement of this data spaces integration. So just to, I think that it's all going to end my slot. So just a few takeaways, because first, we see that there are well-adapted standards on application level. As you mentioned, they are not solving all of the problems, but the application level of the location data sharing, they are quite various. They are addressing they're addressing various needs, as mentioned, from streaming on the web to really processing the huge amounts of data on the cloud, on your premises, and any other aspects. We see that the location and spatial temporal aspect is important for everybody who's dealing with this kind of data, because it matters for the data providers. They are local, national, global, or really citizen science data is different scope and area of interest. It matters for the processors, because as mentioned, without the location ingredients, the data is actually meaningless. And really, you need to combine you need to be aware of what data you are dealing with. And for the end users, because they are used to some scenarios, and they are used to take the area of interest and really looking in this catalogs, for example, where the place is, and combining this data vertically on this location. And naturally, as mentioned, this is also cross-sectoral. It's actually tackling many aspects of our life, meaning that the data is produced in many sectors. And as the value of the interoperability, I guess main value of the interoperability is this added one, which is providing more economic opportunities, is really the challenge to combine this in the data spaces, for example. And we see that there are many connections with the data spaces throughout our members. Some of them are already active in this group. And also there are some silent ones which are simply implementing and maybe not so visible as the others. And maybe this is something we should improve. Therefore, we have also this license and MOU with some organizations that are clearly working with the data spaces, like the ESA and OASC. I guess it's also kind of data space, but also with the others, which are global and maybe more generic, but they are hugely contributing to the tools that are able to be used in the data spaces. And it's all done for this coordination and effectiveness. And I hope that this location data space is also something that we can contribute to and work on this leverage. And that's probably all from my side for the moment, but happy to hear your questions.
Thanks, Piotr. I suggest that we move on to Adrien, and please write your question in the Q&A panel, and we will address both questions to Piotr and Adrien at the end of this first session.
Adrien? Right. all, and thank you again for the invitation. Is it all right with my screen?
We don't see it yet.
Okay.
Yes.
Okay, great. So yeah, I'm working for CS, which has been acquired by Sopra Steria about a year ago. We've got 40 years experience in space. And basically the main reason why we're here this morning is because we're heavily involved in location data, either through Gaia Data, which is a French initiative, DIDO, which is Destination Earth Data Lake. So these are references that have been quoted before, either by Ulrich or by Emmanuel. And we also involve through our mother company in Simple, which is the large-scale modular middleware platform that has been mentioned before again. So as we have been involved in there, I want to take you through different stories this morning that actually affects our everyday life. But before doing so, our approach as CS Sopra Steria towards data, and actually I go back to what Piotr mentioned about having the data findable, accessible, interoperable, and reusable. We actually ask ourselves the same type of questions. Does the data exist? Where is the data? And the third question, how will the data be used, which addresses the interoperability and the reusability of data. First, primary use case is about space safety. You probably know that our everyday life is actually sustained by space-based assets. We are actually geolocalized through our GPS system in our cars, through satellites. Agriculture actually is also sustained by satellites. We have also satellite communication. So we have a lot of assets that we don't see actually, obviously, but are actually flying over our heads and that are serving our everyday life. And this is about space safety. That's the first case I want to take you through. You probably have heard that there's been a lot, and there's more and more debris and satellites flying over our heads. And I thought these infographics from ESA very actually self-explanatory. As we have more and more debris flying over, the space assets, meaning the satellites, are more and more a threat, and we need to do stuff about that. So how can we actually mitigate the risk of all these debris affecting our everyday life? So that goes through actually data collection from different sources, and therefore these sources need to be aggregated somewhere. And what we are looking of from an industry perspective is a data space that could actually join all these sources together for us, CS Sopra Steria, to be able to process the data in a very structured fashion and to be relevant. So today we're actually going one by one source after the other, to be able to carry on that duty. So what we wish to have is a data space actually for space safety. That would be super useful. And actually this is to secure all the satellites that are affecting our everyday life once again. So that's the first example I wanted to take you through. The second one is about journalism. So what we did is we built a platform called Callisto, addressing environmental journalism, but not only, could be war journalism. And here are pictures that they are not from our platform, from Callisto, but it's been taken from the recent news, which is, you probably have heard that Ukraine has actually hit a satellite control center in Russia. And what happened is there's been some news arising on X, and then people wanted to actually investigate what happened. So they had to go on and look at Sentinel-1 information. And based on that, their investigation led them to actually order new information from Maxar and actually to cross-check this information from other sources as well. So here again, we have a need for journalism of merging the data together. And again, location is super useful in this instance. Why? Because journalists, what they want to have is to be alerted about unusual events based on different laws or rules that they have set for themselves. And Callisto does that. They want to have details on evidence that are powerful to be able to actually write an article about that. and they want actually to get rid of all the false alarms. So our role at Sopra Steria is to build a processing actually platform, but we need the data source, the location data, to be able to pick the information from. And the more information we have out there, the better, because then the journalists can actually carry on their work in a proper fashion. So that's the second example I wanted to provide to you. And the third one is a tool that we built for the firefighters. We always come from a customer needs in the first instance. And what was our target is to actually provide a system of alert that will bring an alert within 5 minutes on wildfires monitoring. With only satellite data, this is almost impossible to do unless you're very lucky that a satellite actually passes over an affected area at the same time that the request is being made. So what we built is actually a combination of data using satellite data that are parsing every day over the Earth, then can look at the hydrological stress of vegetation. Based on that, we are actually including other vectors, which are the aerial vectors, such as airplanes or balloons that actually can fly over certain critical regions. We can launch and integrate drone data as if we need to actually look in a deeper fashion a certain area. And then we also integrate mobile alerts, as similarly to the previous example, where actually a piece of news was actually broadcast on X. We can actually look at all the mobile data, such as the activity in a given area. We can look also at keywords, and all these things together, along with IoT and video surveillance in certain areas. Actually, it's the mix of all that data that can allow us to bring down this reactivity time to 5 minutes with the aggregation of all these data. But once again, this has been done in a case-by-case fashion. What we were really missing here is a location space data space that would allow us to facilitate that work, actually to bring down our cost of plugging ourselves to every source of data, and to focus more on the data sharing, data processing, algorithms that will actually help and facilitate the decision making of the firefighters. I'm finished on what we're doing at Sopra Steria. So we are 40 years old company that's been acquired by Sopra Steria. Once again, we're nearly more than 1,000 people, and our breadth of actually activities range from consulting to staffing through system engineering, product solutions. We also have activities in GNSS, observation, space safety, as I mentioned, satellite communication, human spaceflight, and in-space servicing. And our customers ranges from space agencies down to non-space players, such as insurance companies, energy companies, and insurance companies as well, firefighters, and so on. Thank you for listening, and I'm happy to answer your questions if you have any.
Thank you, Adrien. So Adrien's presentation was the last one in this first session related to multiple perspectives on location data. I've seen one question in the Q&A that I replied to, but happy to get additional views. So the question was from Agnello Gentile. What should be the localization requirements, both geographical and legal, for data centers hosting location data spaces? My answer was it's up to the data owners and the services providers to decide what are the prerequisites for hosting their data and services on a given IT infrastructure. But that's exactly why Gaia-X is providing its Gaia-X labeling framework to be aware what are the geographical and the legal rules that are applying to the service you'd like to access. Anyone willing to complement this my answer related to Agnello's question. Victor, I don't know if we are able to share links to the audience. It would be interesting to share the Gaia-X labeling framework link. It could help. And would you like to follow up on this, or are you happy with my answer?
Yeah, maybe I can add that apart from this legal aspects, and naturally we have the regulations that the data processors should conform to in Europe. We have also these practical issues, and the way the data is processed, the amount of data is naturally impacting the location of the data, but also the users who are accessing the data has different needs. And if we are talking about these cases like the fighter one, we have the combination of online sources and kind of degraded environment sometimes when we have to address these issues of low bandwidth or even loosey connections, which can be supported by technology, but it's also a matter of having the data right in the right place in the right time.
Actually, Piotr, on this example, it's a very good one because let's say we had the example, we worked with a partner here, a Greek partner, and what came out is where the fire broke up actually was not necessarily where the most keywords came out actually. So the people actually who were living in the countryside called their relatives in Athens, and actually these keywords came up more on the Athens region or area than where the fire broke up actually. So this is something actually to look at as well. And obviously there's what we talked about in the data accessibility, interoperability, and reusability. There's also a way of fact checking the data, obviously, just to avoid sending the wrong message or to have any bias in understanding the data.
Adrien, I don't know if you have noticed, but you have a question addressed to you from Crazy Listen. I would like to know more about the use case of Sopra Steria and wildfire. How do you task the use satellites or with archive, as well as airborne at the same time in the same location to gather updated data up to date to be able to do an alert in 5 minutes? Do you have a geographic area limitation of surveillance?
That's a very good question. So what's the framework? It's like kind of an onion layer mechanism. So we are using, as satellite is used with, we mostly use Sentinel actually data, Copernicus data, because they are free. We've got free access on that. And the idea is to parse, actually use all the data that goes around the Earth as satellites pass over. This allows to have some kind of a long-term surveillance on specific areas. And then based on radar data and optical data, we can actually send some requirements to actually fly over specifically with airplanes, balloons, or drones as we see an hydrological stress somewhere or an area that might be subject to wildfires. And so we have the top layer, satellites, balloons, aerial, drones. We have, well, obviously we are limited by means and by the price or the cost of all this running. So we use as much data, public data as possible. And we actually pinpoint the areas at risk, and we leave it to the firefighters to actually have a check on the ground if need be. So it's the combination of all this data that allows to bring to 5 minutes. And if I actually go back to your question, and we can task data, satellites, if we actually need to have a closer monitoring when a fire has caught up, actually, either with all the satellite operators. So the combination of all this information allows to have a proper monitoring. Second question could be share a homogeneous view about levels L1 and 3 of data? Absolutely. So that's exactly the case. So data is actually treated over. So we start from L0, L1, and so on. So the idea is obviously to get something. When we deliver information to firefighters, we can't deliver L0 because this is not exploitable by the the man in the street. So what we bring is as much insight as possible on the imagery as possible to actually facilitate the decision-making process.
Thanks, Adrien. Any other question? I don't see. Yeah, thanks, Danilo. So I suggest to move to the second session of this locations data space webinar. That's a session related to use cases. We have three different presentations from three very different domains. So it will be the user side, and Thorsten Reitz is the first presenter related to InGeo-X. Thorsten, the floor is yours.
Good morning. Thank you very much. I hope you can all hear me well.
Yes.
Okay. And the screen sharing also works?
We see your screen. Yeah, we see full screen. Super. Thanks.
All right. Great. Thanks a lot. Yeah. Good morning, everyone. And thanks a lot for the invitation to this event. Yeah, what I'd like to talk today about is basically the work that we've been doing within non-for-profit association together with a wide range of partners actually to establish a trustee for sensitive spatial data with a focus on Germany right now. But before I dive into the concrete use cases, why we're doing that, yeah, I think I'll start a little bit higher. So basically, this is something that I guess in this community is really clear, but in the end for us, data spaces are about making the data economy work. And when it comes to location and spatial data, there's still a lot of data that basically sits on shelves and is not really being reused. And especially in the use cases that we work a lot with, like in forestry, in some countries, even the digitalization is still quite low. And so getting to a point where we have really proper reusable data and also solutions that are applied to that is still a bit of a path to go. Of course, there's also always the critical perspective on making sure that especially sensitive data isn't abused, that there are no accidental releases, etc. So making sure that all of that works and at the same time we can make this data economy work. That's why we are fully committed to the idea of applying data spaces. So one of the common questions that we often see being discussed when it comes to going to data spaces is whether we are actually talking about islands or networks. So I think it's pretty clear that each of just these four examples is already a really complex data ecosystem. But, and that was also highlighted in the presentations before, and it's a general topic of today, of course, is there's a common element to these, which is that often geospatial data is a key component of these data spaces and of the solutions. And obviously, especially from the side of the OGC and from others, there are standards for all of these things. There are also from the community semantics and other things that have been defined. But at the same time, what we see in the concrete implementation is actually a lot of heterogeneity. We see actual redundancy happening despite all of these standards being deployed. There's incompatibility already growing, kind of in this early stage of the data spaces being established. And we generally also see that there's quite a bit of inefficiency because of these redundancies and incompatibilities being generated. So especially when we think of data spaces being something that works on a more cross-cutting level, I think it's really important to look at the standards that are there and to make sure that we're aligning, especially in the case of location, which is such a cross-cutting topic. If we go one step deeper, so what does that really mean when I say there is actually cross-cutting data? Then let's have a look at the use case that we've been working most on for about 5 years now, and that is the most mature, I would say, from the ones that we've been involved with. The forest data space that we've been developing mostly aims at supporting forest owners and practitioners in adapting their forests to climate change. So it's not so much about the production chain, so what happens when you cut the tree down and then send it to the sawmill and so on. But our focus is really understanding the health of the current forests, understanding when you need to change something in these forests and what you can do then, like what tree species to plant, what method to use, etc. And for that, there's a lot of data that involves these kind of decisions, like the ones that are mentioned here. It starts obviously with things like weather and climate data, forest inventories from national to local scale, but also many other things. And quite a few of these data sets are neither very accessible, so they are here on the left side of the bottom axis, nor are they very usable for the particular use case. Now, some of these are specific, but there are also ones like soil data and water availability that are obviously very common. So those would be data sets that we think would be best served in a horizontal infrastructure and made accessible to a wide range of use cases. So if we go outside a little bit more, obviously that's not everything. There is a lot of sensitive location data. And in general, I'm super happy to see that there has been so much open data in the community, like, for example, in remote sensing data and so on. But it's also clear that in the environment that we are currently in, it's not possible to make everything open, like sensitive and critical infrastructure, or even the exact position of protected plant and animal species. Yeah, you still want to maybe process biodiversity in an exact way, but at the same time, unfortunately, if you release exact locations of, for example, where wolves are found, somebody will go and shoot them, which might not be desirable. Yeah, then there's economic data that conveys an economic advantage, for example, or simply consider proprietary knowledge of organizations. There's very specific things like benthic data for assessment of wind turbine deployments or data for geothermal projects, which kind of fall under this category as well. So they give some specific insight that can be a market advantage and is therefore not shared openly and was also maybe very expensive to generate. And then, of course, there are certain legally protected types of data, like personally identifying spatial data. So for all of these, we need to have ways to share them, to process them in a way that respects that they are sensitive. And that brings me to InGeo-X. So we saw there is basically a lot of activities already in the other presentations. We have so many different groups working on different aspects. But the thing that we kind of saw is that we really want to take all of the frameworks, the recommendations, and so on, and see how we can apply them really specifically to a set of given use cases. And that requires filling in a lot of gaps and making things far more concrete, like taking the rather, for example, abstract frameworks that we have at the level of the Data Spaces Support Center, or even which are more specific already for something like the Green Deal data space, and then really thinking, okay, what does that mean? What components do I need to deploy? What standards do I need to agree on? And so on. We kind of want to do that within InGeo-X for use cases that are inherently spatial. There are quite a few challenges to address in that. Oh, okay, sorry, I obviously managed to not translate this slide fully. But basically, the main challenges that we have are that there are, for example, still a lot of uncertainties about basically who is required to contribute to such a data space. There's also, I mean, in the Data Spaces Symposium in March in Darmstadt, there was a lot of discussion about things in the data spaces world already being piece of cake, but fact is technical and organizational complexity of establishing data spaces is very high, even when you try to use all the resources that are there. There's still many, many detailed questions, and that's no surprise. Yeah, collaboration across many different actors is always non-trivial. I also still think that the technology and infrastructure, the common infrastructure, especially if you look across Europe, it's still not that ripe, so you can't just plug in and get started. And of course, there are challenges like, will there be critical amounts of data? Will the interoperability be fully guaranteed on both the control plane and the data plane? And for us, the big step that we can now announce that we will officially start actually on Monday with the kickoff. So the contract has started a month ago. It's a project called InGeo-DTM, so DTM. Basically, that's not digital terrain model. I only realized that this could be confused today. It's actually a data trustee model for horizontal geodata spaces. So what we want to provide basically together with the partners which include a lot of associated partners and data providers and so on, is to really build up a trustee that follows geospatial data space principles and tries out value chains with this data in a data space along certain use cases. The actual trustee is going to be the association that I managed at the beginning, the so-called InGeo Forum. So it's got a pretty wide and diverse membership. It's obviously, as a non-commercial association, it's also neutral. And the members can basically take the different roles that are required, such as federators, data holders, users, contributors of R&D solutions, and so on. Could be that later we also aim to get that trustee to become a recognized data intermediary. The process that we will use, as I mentioned before, it's something where we start with the concrete projects of the partners, which includes the forest data space, but also other ones, which instead of running separate, which they did so far, will use a common test bed. And in this test bed, we will basically try out different things, both methodological and technical, and then derive a reference implementation and blueprint from that. So something that can be simply used to establish different data spaces that are dealing with location data and that are compatible and interoperable in most aspects of each other. And obviously what we do is we rely heavily on OGC standards for that. So I mean, that's something that I've personally been active in for more than 20 years. But obviously for the control plane, we rely heavily on the IDSA standards. And we're testing, so for example, for typical cases like, can this person, this user, this organization access data in that particular location? We're looking at, for example, how an overall interaction between connectors, clearinghouses, and other components can be set up to establish that. The end goal for us really is to have these use cases that are kind of cross-cutting and that sufficient interoperability between location data in different data spaces exists for those. So for example, one of the use cases we have in the project is called turbines in forests, Wind im Wald in German. And obviously this needs data from the forestry side, but also from the energy side. So some basic measure of interoperability has to be created there. So to conclude, I think we're all aware there's still a lot of work to do. And yeah, I find it super interesting to see all the developments happening from the top level down to very specific activities. And what we are now building is basically an environment to apply these concepts and components to geospatial data, to define certain minimum interoperability mechanisms. As a side note, I've just completed work on a technical report with the JRC that describes a lot of these things in detail, should be published any day now. And yeah, also to create synergies and remove redundancy. So instead of kind of trying to find solutions how to use certain common data sets everywhere, get everybody together and see that the stuff can be used many times. Yeah, and all in all, make it easy to share and use sensitive geospatial data by building on existing standards and infrastructures. Obviously, there's a lot of potentials to combine this with other projects and initiatives, so feel free to reach out to us to see how we could collaborate. And that's it from my side.
Thanks, Thorsten. As you have a hard stop at noon, I suggest that we move to Gaël while addressing the second use case, maritime. While any question addressed to Thorsten could be done through the Q&A panel, and then Thorsten will reply online, and if needed, at the end of the presentation of Gaël, Thorsten
do you see? Sorry, do you see my screen?
We see your screen, which is the Zoom. So we don't see your presentation. We see in fact, we see my face.
See. Oh my God. I don't know why.
Thorsten to be addressed online.
If not, I guess everybody will know how to find me. So thanks.
Now you should see it. Do you?
Yes, it is coming. Antti and Thorsten, you have a question from Piotr in the chat.
Yeah. So should I try to respond now or in the chat?
If you can try to respond now while
Okay,
Gaël...
yeah, I'll do that. So generally,
maybe you should read the question because
yeah. So the question is, are there requirements you recognized for the OGC standards that shall be addressed? What is the right way to do it? So I guess one common question is actually how to express vocabularies and semantics across the control plane and the data plane. So really sharing common concepts also in the contracts and data usage policies and so on, and really building on top of what is already defined on the data. And right now, sometimes these things are done separately, and it might make sense for the OGC to kind of look into how the vocabularies that are used more on the control plane for expressing, for example, contracts and so on could be brought in line with what's already there on the actual data and API side. Like, for example, the APIs clearly specify operations, and then there's another set of things defined for operations in policy languages and so on. So I think that's a potential area for sure where there's some alignment. Other than that, we basically treat the existing APIs, especially the new ones like OGC API features, basically one-on-one. Something that we will use for the data plane in a data space. Works very well in my view. The things that are there so for that might be added, I think are very deep dive things. So I'm not sure if now is the right place, but I'm happy to follow up with Piotr or anybody else to discuss that.
Thanks, Thorsten. Gaël, we see your slide full screen. Woo!
Okay, that's nice. So thank you for having invited me. The presentation I will make will be a little bit different from all the other one we have seen, because actually I'm really a basic user, I would say, from a researcher perspective. So it's something different as when you're selling a product, probably. And the application I've chosen is sea level rise and how to use location data for that topic. Actually, sea level rise is an application of geodesy, and geodesy is all about measuring the Earth, its shape, orientation in space, surface, gravitational field. It means that in geodesy you will both generate data, meaning GNSS positioning, for instance, and also use location data. So for topography, to monitor landslide and all kind of stuff. And one of these applications is sea level rise, and the acceleration of sea level rise and acceleration, yes. Sea level, you may know, is due to the melting of glaciers, so adding water in the ocean, but also water expansion due to rising temperature. And it is said that the sea level rise has increased by approximately 3.5 millimeter per year since 1992 and may reach nearly 1 meter in 2100, so at the end of the century. It means that it's not a few centimeters, it's quite a lot, and this will have a major impact on coastal cities, but also on atmospheric masses and so on. So it is so important that it was defined as essential climate variable by the Global Climate Observing System, GCOS. So sea level rise is an essential variable, but not only sea level rise, also the uncertainty which is associated to sea level rise, because I can say, okay, it will be 1 meter globally, but plus minus 1 meter, and it doesn't make sense. So it's also very important to assess the uncertainty. For sea level rise, so as an essential variable, it is important to monitor it, to understand it, to predict in order to find mitigation strategy. So for such half Iceland that may disappear in a few 10 years, 20 years, don't know, it is important to find mitigation strategy. How do I deal with the building there and the infrastructure and so on? Do I have to move them Okay, so it is yeah, very important to be able to locate where that happens, and also how much, which is associated with where in the past, in the present, and in the future. So where is sea level rise increasing, decreasing, where it is accelerating or decelerating. You see, it's a global process with regional differences. And the many kinds of data that you use to study and to find mitigation strategy reflect this specificity. You have spatial data, but also terrestrial data. And you also have data that allows you to make investigation for cities, for regions, for the whole world, and also for various time scales. So years, hours for nowcasting, and so on. And the research, which is linked with all that kind of data, reflects this high variability and spectrum. So you need spatiotemporal data. I will just introduce you to 5 kinds of data that we use and show you how we access to this data. The first one is tide gauge. This is the oldest one, and you have tide gauges all over the world. They record sea level at a daily rate. And because you have tide gauge for sometimes more than 100 years, you have very long-term records, and it's very interesting to study natural variability, and detecting trends, and using machine learning techniques. You have to take care of tide gauge. It is a relative measurement of sea level, meaning it refers to the Earth's center of mass. And tide gauge is influenced by vertical land motion, meaning the movement of the Earth's cruise near the tide gauge. The tide gauge is mounted on a fixed waiter above water. And in order to correct the tide gauge measurements from vertical land motion, meaning, for instance, it may be just natural movement, the Earth which is moving, Earth's cruise moving, but also, you know, if I start jumping all around the tide gauge, this will affect the time series, and you will see that, so that I am jumping a few days long if I make a lot of sport. And you have to account for that. Otherwise, you have bias quantities, bias sea level measurements. And this can be done using location data. So location data, not to locate, but to correct the measurements. Another way to use GNSS data, not for location, but to study sea level rise, is by using reflectometry. So the fact that there is multipass, and the wave are reflected on water and recorded by the station, direct and indirect signal, and you can derive sea level also that way. The third way is satellite-based measurements. Satellites are, you can measure sea level just by making the difference between the altimeter range and the height of the satellite, which you know because you know exactly the position of the satellite on its orbit. And by taking the difference between the two, then you get information about the sea level. But take care, it is an absolute measurement in that case, so it refers to the Earth, to the reference ellipsoid. So for tide gauge, absolute or relative; for satellite altimetry, absolute measurements. And when you want to compare both observations, you will have to make some kind of conversion. Two last possibility, surface soil moisture. A small contributor to sea level rise is a decline in the amount of water on land, lakes, reservoir, rivers, and also soil moisture. And you can access to such information by means of Sentinel, so Sentinel observations, remote sensing mainly, And yes, it is an important contributor to sea level rise. Last possibility is to use GRACE and GRACE follow-on observations, which are satellite-based observations also. GRACE is a joint mission from DLR and the NASA, and the primary goal is to get information about Earth's gravity field anomalies. But from such kind of observations, you can also access to terrestrial water storage or ocean mass changes. And it provides invaluable contribution to monitor water storage decline by means of groundwater and to study droops, yes, the amplitude, predicting them. So for sea level rise, also interesting. So most often you will never use just one kind of observations when you're doing research. So just tide gauge, just satellite altimetry, you will try to combine, to compare, because it's important to assess, if you remember, the uncertainty. On the left, on the bottom, you have three globes, and that's how a combination of different information, different sea level rise informations, then you can get to causes of sea level rise. If you combine satellite altimetry, GRACE observations, ocean mass change, and you take the difference between sea level trend and ocean mass change, and you get information about the cause of sea level rise, which is the so-called steric change, meaning the fact that water is expanding due to the rising of temperature. And by combining this information, you can get this valuable contributor to sea level rise. So we have seen 5 kinds of observations. It means 5 kinds of observations to study sea level rise. It means quite a lot of platforms. Because unfortunately you don't have such kind of nice shop such as or platforms such as Copernicus for sea level rise study. There is a one-stop shop called GeoS, which allow to access to all kinds of observations I've spoken about. Tide gauge, satellite altimetry, but also the information that's allowed to make the conversion between absolute and relative sea level rise. And yes, a problem from a user perspective is that, yes, that's a problem of one-stop shop. You have to go there and click, and then you'll be redirected. You get another platform and another one, and it's always different. And it's not homogeneous. And each time you have to understand, you have to find out where is the data download button, where will I download exactly? So it's always quite, tricky and complicated. I have to say complicated and also risky. Why risky? Because you have different time frame, you have different data source. And if you want to combine them to make some machine learning prediction, for instance, then you have to take care of what you put in. And that's the main problem of such platform. When you think about Sentinel data, you have this Copernicus store, which is very, very nice done now. You have an homogeneous platform, and it's always clear where to click to have access to the data. So the work that is done in the Copernicus program is really valuable for researcher, but it's only for that kind of observations and not for sea level rise, tide gauge, satellite altimetry, and so on. For GNSS observations, you have IGS platform, for instance. So you have a globus, all the stations available around the world. You click on one, and then you get access to the here on the left to the log file for your stations where you can download the observations. However, for most of my application as a researcher, I have to correct this information for instance, non-atmospheric loading or hydrological influences. So I just do not need only these informations, but also other one, and I have to search on my own where they are. So it means that actually it's, as I say, it's always a lot of stuff. And as a researcher, I am really dreaming from a kind of Earth observations Amazon store with all services provided, access to the data, someone who would be able for me to download, process them, make them homogeneous. So, so that as a researcher, I am just able to concentrate on what is the core of my work, meaning developing new technology, new algorithm, finding new way to process the data, to get accurate information about sea level rise, but it's also about turbulences for all kind of things. So where you need location data, because I have various platform formats, sampling rates, time frame, gaps, outliers, noise, and so on. And yes, this would be my conclusion for this presentation. So my dream would be such a kind of store with everything available on one platform, and very, yes, just thinking of an Amazon store with services so that I can concentrate on my own work. Yes, so if you have any question, I would be happy to answer them. Otherwise, you can contact me then if you have further questions from a researcher perspective. Thank you for your attention.
Thank you, Gaël. Thanks a lot. Super interesting from a totally different domain. But we have seen that you are gathering a number of very different location data, and you are producing as well. You are both a user and a producer. Any question to Gaël? Gaël has a hard stop in 1 minute, so you have 1 minute to raise your hand.
It's 3 minutes, okay.
No question?
Well, if there's no question,
I see someone. Piotr, you have a question?
Yeah, so you presented the great work of improving data quality. So it may be a bit provocative, but are you sharing that data also? Would you be interested in sharing this outcome data? And the other one is more, let's say, technical. Is it the well-described space that you could provide is data quality assured? And so the clients, the other side, could be really aware of the value of that.
Well, actually, from a researcher perspective, we always want to share our data, that for sure. Mainly, you will write an article about what you're doing, and then you have your observations or your algorithm in GitHub. Nowadays, when you are publishing, it is encouraged that you always give access to your data. And mainly, as I said, it's done on such kind of cloud platform at your university, for instance, or GitHub. Yeah, and there's no way to do that so homogeneously. But that's your own, your own work to share. In research, we want to share, actually.
Thanks, Gaël. Any other questions for Gaël? If not, we are moving to Marie-Françoise Wardot. The Geo Knowledge Hub is a good place to share such work. Geo Knowledge Hub.
I will write it down. Thank you.
Maybe Marie-Françoise, you can share the URL of this Geo Knowledge Hub. Thanks. The third use case will be presented by Anne, who is working for the company based in Belgium, Gaia, and it will be about road infrastructure across 3 countries.
Yes, indeed. Okay, so I think you can see my screen now.
Yes, full
The
screen.
presentation. Okay, so thanks for the introduction and thanks for the opportunity to talk here a little bit about an ongoing project that we are doing, a feasibility study to evaluate the implementation of a digital twin for road infrastructure managers in the Benelux.
And just to mention, we are not seeing you anymore.
Ah, oops. Why is that? Display. What did I do?
No, anyway.
Ah, okay, sorry.
Yeah, super, perfect.
Better like this, okay.
Perfect, thanks.
Okay, I'm sorry. So here I am. So next slide. Quick overview of what I'm going to present, a short introduction on GIM, the company I'm working for, the context of the project, some words about the project itself, and then the scope and the first insights, because it's still an ongoing project. So I'm working at GIM. It's a geodata and GIS company in Belgium, located in Belgium. We are focused on data, more specifically on geodata, to respond to the needs of our various customers that we have, to take decisions based on geographical data. And we do that already for almost 30 years. And I have 75 colleagues that are happy to work for our customers and doing our projects. So our main expertise is situated around 3 pillars. Geodata engineering, so we are making your data work for you, everything related to geodata. Transformation, enrichment, data qualification, and publication. Geo-ICT, which means the development of web applications and mobile applications where a map component is present. And since some years, we also work on geospatial AI, where we develop AI models to work on mostly computer vision to extract information from all kinds of imagery. And we are active. We are doing these activities in different type of business sectors. So for the government, local and regional and federal authorities, also for the private sector, and for the utilities and telecom sector. And for each of these sectors, we have different solutions that we offer to the market. And myself, I am the team lead or the business unit manager for the public sector team that is mostly serving governments in Flanders and on the federal level in Belgium, as you know, the Belgian situation. But okay, enough about GIM and myself. So let's have a look at the project that we are talking about today. So I will first explain a bit the context where it came from. You have all these road infrastructure managers in the Benelux that are managing the road infrastructure, and where often replacement or a renovation of this infrastructure is needed. The modern road infrastructure manager is also encountered by a lot of challenges, like the digitalization, the decarbonization, but also climate change and urbanization provide large challenges within the road infrastructure management domain. And so this is why the project partners want to come to a more intense way of exchanging data to cope all of these challenges. And so they were thinking a digital twin for road infrastructure might be a good platform or a good tool to support our well-informed decision-making, so where we can cross-border share data with each other to help each other on this on our day-to-day business and tasks that we have to do with respect to road infrastructure management. So the goal for the digital twin that they are thinking about is to come to better data and information exchange between all these project partners to help them to take better decisions. So that's a bit the context of the project. So then the project itself, so it's about a feasibility study. The coordinator of the project is the Benelux Union, and there are 4 project partners from all over the Benelux involved that are indicated as the stakeholders for this project. So in Flanders, you have Agentschap Wegen en Verkeer. At the Walloon side of Belgium, so the southern part of the country, we have Mobilité Infrastructuur from S.p.A. Then the Netherlands are also taking part in the project. There you have Rijkswaterstaat with the Ministry of Infrastructure. And for the Luxembourg, there is the Ministry La Mobilité et des Travaux Publics, and more specifically the Administration des Ponts et Chaussées. So we have all these 4 project partners, and they all have one common goal for putting this project into place. Namely, they have this idea about this digital twin, as I explained before, and so they want to know more about what it will mean to develop it. So what would be the amount of time to develop this digital twin? What are the costs related and the efforts related to this development? But also give us an indication of the enablers and the barriers for this project. So it was put in the market through a call for tender, to which we replied from GIM. But we did not do it alone because what I still forgot to say is that the legal aspect is also a very important part of the project to be investigated. So within which legal boundaries can we cross-border share all this data? So we teamed up with the University of Leuven, a specific part of the university which is specialized in the legal and the ethical aspects of IT innovation, the legal analysis of development and deployment of digital twins, and so on, where we, from the GIM part, are the expert in GIS and geodata processing, as I explained already before. So also the GeoAI and geodigital twins are things that we are looking at or working with. And we also have a lot of experience on building spatial data infrastructures for cross-boarding data, namely conform with Inspire and the high-value data sets. So where we are also active in the governmental sector in Belgium and Luxembourg for many, many years. So it's a feasibility study. So we follow a specific approach to get grip on the situation and to search for the enablers and the problems that might occur when establishing this digital twin. So first of all, together with the project partners, we defined the scope and the objectives of the project, and we built the definition of what for them means this digital twin. I will come back to that in a minute. Then based on this definition, we had workshops with all the different project partners to evaluate their current situation and to capture their needs, to get grip on their needs with respect to the digital twin, of course. The next step is then based on what we learned in the previous step to develop a solution for what they need. So there we will look at the use cases, the data that is needed to be able to serve this digital twin, the legal aspects, the technological solutions, all these things. Once we have the solution in place, we can evaluate them through a cost-benefit analysis. And the last step is then to put in place a proposal for an implementation plan to really start with the implementation of the digital twin. So as I explained before, together with all the project partners, we defined the definition for this digital twin. So how they see it in their head, that we agree all on what we are working to. And so the most important aspects are covered in this definition. So it has to be an interactive digital representation of the road infrastructure assets that they are managing. It will be a 2D high-level road network, where we start with a simple level of detail, mainly the center line of the road sections. The data that we share, that will be shared through the digital twin, needs regularly updated, so that we always have a qualitative and complete representation of the real situation. And also that there is the possibility to integrate with external data sets to enrich the digital twin and the tools that will be provided. Those tools, they have to serve the production of reports and to give insights into all the aspects of the road infrastructure management, like the status, the performance of the road network, future opportunities, voila. And for that, it needs to serve as a baseline for cross-border analysis, decision-making, and strategic agreements. So this is more or less, in a few words, the definition that we set up front. And then we went to, we looked at the scope of the digital twin. So as I already said in the definition, the digital twin is on a network level. So it's not on a BIM, a building information model level, to be able to start with a good and useful version. The geographical scope, yeah, we are working for the Benelux. So it's the full version will be for the Benelux at first instance. On the level of the highways and the regional roads. So the local roads are not included. And to test the solution that we will work out in the project, we will we have collected the data from the project partner that is available, and we will see how it matches on a demonstration and validation track that runs over through all the countries of the three partners. So it starts at Rotterdam, it goes to Antwerp, over Brussels, Namur, and to finish in Luxembourg City. So for this digital twin to be feasible and to be of use of the project partners, it should answer to some specific use cases. The different use cases that all the project partners think about, we captured during the different workshops that we had, and we discussed with the different partners. When we had the overview of all the use cases, we did a SWOT analysis for each use case, and we checked the use cases to the definition of the digital twin for road infrastructure management, as we have put in place in the first steps. And more specific, we checked every use case on the interest of the different project partners for this use case, the cost and the effort that the implementation of this use case might bring for the different project partners, and the cross-border aspect, because yeah, this is one of the main goals, to put in place a cross-border digital twin. So we did comparison, and then we had a conclusion for each use case, an evaluation for each use case, where we say, okay, we will further investigate this use case. This use case is fit for the first version of the digital twin, or it brings some opportunities for a mid or a long-term version on the longer term. So before we dive into the, yeah.
Yeah, sorry to interrupt that. You have a couple of minutes
Yeah, okay.
Thanks.
So before to dive into the specific use cases, there is also one horizontal use case, and this is in fact about the sharing of data on the cross-border and a cross-sector basis, including the legal framework. And so the evaluation that you see here on the slide is the evaluation that we did for all the other use cases as well. So we checked the three aspects of the definition: interest, cost, effort, cross-border, and then we came to a conclusion for the implementation of this use case. And for this use case, yeah, the conclusion is quite simple. It's the main goal of the digital twin. So here it's also the main use case for the first version of the digital twin, with opportunities to grow. And it is advised to work towards a common data model, which is a long-term effort. So the cost effort is yellow or orange, red. This is because we will further analyze or determine how far in the standardization of the road network and the assets of the road network we will go with all the project partners. We can start with a minimum effort, a minimum standardization, and then further in time develop more detailed standards on the data level. So then I have an overview of all the other use cases. And the first use case that we looked at is improved asset management to allow predictive maintenance, mainly for bridges and tunnels. So the digitalized asset management for road infrastructure, this use case has to add value by optimizing the performance, the safety, the durability of the road networks through systematic maintenance, through cost-effective resource allocation and strategic planning. So since we felt at the project partners that there was not the interest of having this on a cross-border level, we concluded that it is outside scope of the current version and that this use case will not be further investigated. The second use case is about energy transition for electric driving. So it's about the rollout of strategies of the charging infrastructure. So in the process of electrification of the mobility and the transport, the digital twin can add value by anticipating trends, future needs, as well as determining current limitations of the available infrastructure. And within this subject, the scope of the use case was rather limited to the analysis of the charging needs and the capacities for the project partners. So the digital twin is not foreseen to be a public access point for charging locations. So as being public is not within the scope for the project partners of this digital twin, but as well, the large amount of alternative tools that are already available for the public can serve this use case. So also here, there can be an interest on the mid or the long term. For the first version, we will not further look into this use case. Then a third use case is about CCAM and CITS. So also here, the electrification of the mobility and the transportation industry, the availability of IoT sensors along the road network, digitalization of data and information. CCAM and CITS forms a crucial technology for the long-term strategy and the vision. So this is for sure enabling, the digital twin will for sure enabling opportunities for this use case, because this kind of this use case will improve traffic fluidity, limit incident impact, support automation and digitalization of the traffic grid. So it really provides a use case for the digital twin in analyzing the needs for the migration towards this modern techniques of serving the mobility sector. More concretely, the digital twin could provide an overview on the achieved CITS level, or analyzing the needs on the managed assets to further increase the level. And it can also provide a uniform data set for cross-border CCAM environment. Not in the first version, but for sure promising as technology improves.
And would you please conclude?
I have two use cases to go. And then it's come to the conclusion. The next one, it's under the umbrella of incident and event management. So there are 3 sub-use cases, which you can see on the slide, which are related to incident and event management. So this is a key responsibility of the project partners to react very quickly and adequately to unforeseen events and incidents. So there, in first instance, there is a very high common interest to deep dive into this use case and to analyze it further and to implement it in the first version of the digital twin. Standardized basis data is already available as well. So this is also an enabler to implement this use case. And for the sub-use cases, the road construction works use case is in fact the most relevant one to exploit further in the first version, while the other ones will be for or mid or longer term, or can be partly covered by the overarching incident and event management use case. And then as a last use case, it was said by the project partners that it can also be of use for communication. But here this use case is not so focused on the subject on which is communicated, but on the communication implementation itself, which requires the definition of key persons, contact points, to simplify the process of communication. So it will not be developed as a separate use case, but it will just be part of the other use cases and as such be integrated in the digital twin. So this overview of all these use cases shows that there is all these use cases will only, or the implementation of all these use cases will only be feasible when the right data with the right quality and the right availability is in place, is available in a kind of data space, a kind of data behind the digital twin. And this is now what we are further looking at the moment. So what's next in the project? We are working on the solutions design. So data inventarization, identification of data sets, both open data sets that are already existing as data sets that are at the project partners, but not yet put in place as open data. What are the requirements of all this data that is needed to serve the use cases that we identified? Which data standards and formats do we need to support or to enable this cross-border data sharing between the different partners? And then we will also look at the technical solutions that can serve this digital twin and in combination with all the legal aspects related to cross-border data sharing. So that's what we are doing. And then the last steps will then be the cost-benefit analysis and the implementation plan.
Thanks, Sam.
And that was my last slide. So
super.
Sorry for that.
Any question to Anne, please send it through the Q&A because we have 20 minutes to go. We are late. And the last 3 presentation, part of the third session are interested too, and I'd like to keep enough time for this. I see Pauline. So I suggest that Ekitia is starting. Pauline, if you can make it in 10 minutes, it would be great.
Yeah. Okay.
And then the 2 projects related to high-value datasets. Pauline, the floor is yours.
Thank you for the invitation, Emmanuel. Can you see my screen?
Yes, in full screen. Super, thanks.
Thank you. Perfect. So, hello everyone. I will introduce you the concept of the territorial data space. So I'm Pauline Zordan. I'm a lawyer and a data governance project leader at Equitia, which is a French non-for-profit organization that reunites 70 public, private, and academic organizations in France from every sector of activity and from every kind of size, from the startup to the big company like Sopra, Steria, for example, or like a region or a small collectivity. Altogether, they build a trusted and operational framework for data sharing and for AI using. So we work on ethical charter, ethical label, on innovative business model, on experimenting, for example, pets, privacy enhancing technologies. For now, 3 years, we have a project with 30 of our members that is called the Multi-Sector Territorial Data Space. It's the result to our 5 past year work altogether is to create the incentive for players to share their data, to collaborate in a digital project, for example. So for us, there is, first of all, it was a concept, very multi-sectorial concept. It was very important for us because all the high-value use cases and data are most of the time created in the multi-sectorial use cases. At the beginning of the project, it was not clear for us if it was a data space or something else. But now with the data space for center definition, I think we can clearly understand our project as a data space. It's not a competitive approach to the European approach. It's completely a current a complementary manner to facilitate the access to data from territorial actors. So the goal is to orchestrate digital resources from a diversity of public, private, and also individual actors to facilitate digital projects on a territory within an ethical framework of trust. You can find, for example, different kind of multi-sector project as public health and environment, or the projects that can you find in the data space for smart and sustainable cities and communities, for example, but also different use cases for industry and privacy, for example. This concept is not just about multi-sector, but it's also a territorial approach. Why? Because we think the region territory is it's an easy way to animate an ecosystem of actors, of players, and to consider the different level of maturity in digital. All the dynamic in the European level are very interesting, but it's not very accessible for all the players on the territory for now. So the interest here is to animate an ecosystem on a territory. The region perimeter seems to be the best one in France, I think, maybe in other countries too. And to, for example, in the south of France, in Occitanie region, where I'm from, we have a strong industry in aerospace with Airbus company. It's very natural for all the actors in this region to have particular access to data, a very specific facilitation tool to improve this industry. So all this innovative dynamic can be built and can be shared with other regions. For example, in France, we can have different kind of innovation that can be shared and replicated in other regions, but also in other regions in Europe. For example, I don't know, but in the south of France, we have the climate changing is very important, very impacting, and we have a lot of tourists. So maybe there is some use cases in common with the south of Italy, for example. For us, it's a way to promote a local ecosystem, to help them mature in terms of data sovereignty and openness, also to facilitate interregional synergies at European level, of course, and to bring innovative local initiative and the needs to the attention for the European and the national levels. The goal is really to bring the European standard and to give it to them, to the local actors, and to observe and help facilitate innovation on territory and to bring it to the European level. The location data are very interesting, as we heard during the previous presentation. It's really in a lot of use cases we can find location data, and maybe in the data set there is all other kind of data, and the location data are not the first that can be seen. But for example, in our concept, you can have different kind of tools that can be built all together, like environmental dashboard to support decision making in the tourism sector, energy management dashboard for industrial building in a competitive sector, or dashboard for managing the process of an epidemic, for example. In all those use cases, you have location data. You have different level of criticability. For example, for the energy management in the industrial buildings, it can reveal different information, strategic information about the rhythm of the supply chain, for example. So it could be very critical. And there is different kind of various relevant reuses. We need to help those local actors to identify all the reuses and to give it to them different governance tools to manage their sovereignty on their own data. So yes, suppliers must have access to governance tools that not only govern access to the data, but also the verified condition under which is it processed. It's why we are working on the rule book on data usage and to give it to them tool to manage collaborative treatment of data. These governance tools must be transposable at both local and European level. Most of our local actors, they don't know yet how they can be a part of this European dynamic. So we really need intermediaries, actors that are not just private one, I think, and not just public one. I think hybrid one can be very interesting. So it's a very quick presentation. I will, for the people who speak French, tomorrow I will do a more detailed presentation of the concept. If not, you can contact me and we can have a chat and discuss more in detail about this concept. But yes, thank you very much. I hope it was not too long.
Thanks a lot, Pauline. If you can share the link related to your webinar tomorrow.
Yeah,
if it's
I will share it.
to register, then we can share it with the audience.
Yeah, perfect.
And feel free to ask any question to Pauline in the Q&A panel. Last but not least, the two high-value dataset projects. And I think Antonio is starting with the presentation, followed up by Lydia, and then Victoria. Antonio, are you able to share your screen?
Yes.
Yeah. If you can make it in 15 minutes instead of 20, it will be great. If not,
can you see my screen?
Yes. Yes.
Now you can see the presentation. Okay. So I try to be very quick. Antonio Filograno from Ingegneria Informatica and an Italian digital transformation company. And I'm the coordinator of the Open project. We, along with the other sister project funded on the same call, in particular the Digital Europe Cloud AI 02, decided to create the HVD cluster project dealing with the improvement of the high-value dataset in different domains, such as meteorological, marine, mobility, climate change, and urban planning. Here you can see a very brief description of the four projects. In particular, the common aim is to improve the quality of the high-value dataset. And, for example, Maregraph will focus on the marine data, Rodeo mainly on the meteorological data, and later on we can see the open and open maps for Europe too, that will be presented right now. So going to the BeOpen project, I leave the floor to my colleague Lydia to present the overview of the project, and then I can go through the technical part. Lydia, the floor is yours.
Can you hear me well?
Yes.
Okay, so very briefly, an overview of it's a Digital European Program project, and the main objective is to provide a framework that allows, that facilitates the access and the use of EU public sector high-value datasets. And it will be tested and validated in 8 pilots targeting mobility, urban security, environment, natural disasters, challenges. And now we are a bit more than half within the project, entering a very interesting phase where pilots are starting to use the framework to improve the data access. Can you go to the next slide, please? So already explained in the introduction here in this webinar, so high value because the data offer substantial benefits when made widely available and easily accessible. So it applies, it's also a policy from the EU since public data is somehow funded by citizens. So now not all data is useful, some is good to have and some is life-saving, helping decision-making. And we'll see that in BeOpen, pilot address flood, wildfire, and other natural threats to society. Several domains are identified and in particular location and geospatial data, but not only, also combined with mobility, traffic, health-related and data coming from, for example, lightning sensors in the city. And so we need to ensure that data, meaning the content, is accessible. And for this, data sets are open, using standard technologies and applying EU regulations. And for this to be interoperable so that they can be used across Europe. So if you can go to the next slide. So the challenge is, how can we help public administration so that they can really use the data that they capture and the content that they produce? And how can we improve the sharing and reuse across Europe of several domains, data from several domains? And how can we take advantage of already existing technology and tools such as those developed in sister projects or other, so we connect also with initiatives that we have seen today. So all those questions, I will pass the floor to Antonio to describe how BeOpen intends to address them. Thank you.
Yes, thanks, Lydia. And we would like, and we are working on provide a technical framework for the data interoperability. We discussed also in the previous presentation about the interoperability with Piotr and Adrien, where the semantic is a key values for the interoperability. We can provide a technical framework to improve the quality, to improve the usability, because the real one of the main aspect and issue of the data sharing is the data usability versus the data availability. We have a lot of data, but in the most of time they can be not so usable. And in doing so, we want to provide a catalog of high-value dataset in order to publish the dataset coming from the city that were improved. And finally, we deliver the guidelines and recommendation that are not only technical, but also legal interoperability of data. What methodology we are using in order to accomplish our objectives. So we collected the needs and challenges in the 8 pilots involved in the project and identified the possible high-value dataset provided by the city. We developed a framework to support the improvement of HVDs, and by using the framework, we are in the time that we are improving the high-value data sets provided by pilot. Then, based on this high-value data set, we define digital service to exploit the power of this high-value data set and develop this digital service to provide added value services to the citizen and the stakeholder. And finally, we evaluate the impact in the usage of new services. As I already said, we have 8 pilots in different domains: urban mobility, climate change, street management, and so on. And finally, what we will deliver at the end of the project: a technical framework, a catalog of high-value dataset, a community of stakeholders where shared the results of the BioPen project, and a smart solution for citizens and communities that exploit the high-value dataset. What are the benefits? For sure, a new way to improve the high-value dataset. We have also a website where we define how to improve, how to follow the EU regulation on the high-value dataset. We are providing cross-border interoperability and less market fragmentation for digital services, and of course standard and trusted technology, leveraging on the previous EU project result, in particular the CIF project. Just to leave you as our motto, built on the blueprint for a common European data space for smart cities and smart communities. So thanks a lot, and I give the floor on time to Victoria to present the second project of the cluster.
Thanks a lot, Antonio and Nida.
Thank you very much for that. It's very exciting to be part of this high-value data cluster together with you. Okay, so it says I will stop your screen sharing, and I hope that's okay with you.
Yes, yes.
Perfect. All right. So, hi, everyone. Thank you for being here and for leaving the best for last. So I'm the project manager for the project Open Maps for Europe 2 that Antonio mentioned as part of the For Open Data for AI projects. My organization is Geographics, and screen sharing. Okay, sorry. I don't know exactly what happened. I think I need to share my screen again. There we go.
Yeah, it works.
The project is that we're leading is comprised by a consortium. So we are the coordinators. 5 of our members from France, Belgium, Netherlands, Spain, and Greece are project partners. We have BKJ Germany and IDOX France as subcontractors. And of course, our members are integral parts of our project because they are the national data providers that provide us with data so that we can provide it in a pan-European format. Now, I say members, not all of you may be familiar with our organization. Geographics is a membership organization, and our members are Europe's national mapping, cadastral, and land registry agencies. So the data use cases that you've heard here today, our members provide at least some of that data, and important, maybe one of the most important parts of our members' data is that it's authoritative, right? It's trustworthy, it's reliable, it's trusted upon by national governments, but also by international institutions like the EU and the UN. And we as an organization are also registered on the EU Transparency Register so that as a gauge to show that you can trust us as an organization as well. Now, what do? We share experiences and best practices. So we enable knowledge exchange in our member organizations. We represent our members' interests internationally. And we also enable the use and reuse of our members' data. And that is what we have in common here today. You need our members' data. We want to facilitate users for users to actually use it. A little bit of context of OME 2. Where does the 2 come from? It builds on to a previous project, Open Maps for Europe, that was also EU funded. Open Maps for Europe was about opening up our pan-European data sets that we have been producing for about a decade and providing it under one easy-to-understand open data license. This is about making the data, the existing data, more available and more usable. During this former project, what we did in addition to provide our data sets openly and also create a prototype for a cadastral map for Europe is that we surveyed our users' requirements. And what you see here, users need large-scale data of key themes, efficient life cycle management and updating. It has to be harmonized and edge-matched, authoritative, and they need European coverage. Now, most of our data sets, or our data set covered most of those requirements, but not the large scale one. Our data sets are down to 1 to 100,000, and the requirement from the users is 1 to 10,000. And we couldn't just scale up our production system to obtain that. We actually had to go in and take a look at if we could come up with a new production system for that. And that is exactly what we did. So in OME 2, which is the current project now, it started last year, right after the end of OME. We are developing a new production process. Just like the old one, it uses our members' authoritative data via automatic harvesting, but they can also send us the data. We do that to be more inclusive. And we use conversion tables to convert each national data set into a European specification. We have tools that we are developing for lifecycle management, harmonization, edge matching, and quality. Now, these are tools that have previously been developed by IGN France and Cadastre Netherlands on national level, and that are being further developed, enhanced, and adapted for these pan-European data sets. And this is important because if we are going to do this every year, it has to be automized. Otherwise, it's not feasible. It's not financially, well, everything is possible, but it's not financially sound, and it's not a sound use of resources. To prove that the production process works, we are providing a prototype at the end of next year. It will have 10 countries and 3 themes, and it will be available via our interface under the same open data license as our other data sets to make it easily accessible and usable. Now, we already have the first version of this prototype on our interface. Go and take a look at it. We have 3 countries. You see them there. It's France, Netherlands, and Belgium. The 2 themes that are in the prototype right now are administrative boundaries and transport networks. We're currently gathering feedback to make the next version better, more user-friendly. Please be part of that. I know we have a few users here today. Go to maps4europe.org, take a look at our data set and give us feedback. Right now, it's available via APIs. At the end of next month, it will also be available via download. Another data set, so the open cadastral map pilot that we started developing, it's a different production process for cadastral data, which is particular. It's different from topographic data in the sense that there are other implications for handling the data, particularly edge matching is something that we do not do with cadastral data. And this is a pilot that we developed in OME and that we are now expanding in OME2. It's a single place to find a European cadastral map. Now, the data service includes administrative units, cadastral parcels, buildings, and addresses. And it's a service that also leads the users to the national geoportals if they want to download the data. So it's a way it gathers the information of Europe's cadastral data. The aim is to have all of Europe in there. Right now we have 6 countries, and we're adding another 4 by the end of this year and another 5 by the end of next year. So in a nutshell, OME2 is developing and enhancing new and existing production processes for high-value, large-scale pan-European data that are aligned to EU policy objectives and UN core geospatial data recommendations, which was very important for us right from the beginning. In essence, it's the foundation for future pan-European high-value data sets. And we're starting with the 6 high-value themes: administrative units, cadastral parcels, buildings, addresses, transport networks, and hydrography. It will benefit a wide range of stakeholders. What this does really is that it addresses the challenge of finding, easily accessing, and licensing authoritative pan-European harmonized edge-matched large-scale high-value geospatial data. That's specific, but that's what our users need. It saves users time, the effort and resources needed because we provide this harmonized data from multiple countries through one central portal and under one easy to understand open data license. We also support NMCAs in implementing the rules for the Open Data and Reuse of Public Sector Information Directive that were mentioned at the beginning of this webinar. And we do that by reusing the techniques that we are developing in OME2. We reuse them nationally and also share good practices. The project will advance the data sharing tools needed to deliver free-flowing interoperable data for the single market. That was also mentioned. The importance of that was mentioned at the beginning of this webinar. And all in all, in a final sentence, OME2 demonstrates how the demand for the geospatial information in all of the common data spaces of the European strategy for data can be met. And thank you very much for giving me your time here today. You're more than welcome to send me an email for questions, comments, or if you see any synergies with your projects or with your uses. And right now, we're particularly looking for use cases. So if these data sets are something that is of interest for you, please send me a message and we'll take a look at that. Thank you, Emmanuel.
Victoria, thanks a lot. You already have 2 questions in the chat. While you're reading it, maybe Antonio and Lydia could address the question from Dominic in the Q&A.
Yes, I already answered. Anyway, Inspire will be our starting point for the improvement of high-value dataset, in particular the dataset related with geospatial, the category, because the high-value dataset are divided in 6 categories, and one of them is the geospatial data, based on Inspire. All the data sets that already complete with Inspire can be considered by default high-value data set relating to the EU regulation.
Thanks, Antonio. Victoria, I hope you were able to read the 2 questions. One is simple from Ricardo. How can a national geographic entity join the high-value datasets OME2 project?
Yes, that's a great question. And I'm happy that there is excitement for this project from the national mapping agencies. So we are including we have, I have to say, we have contacted all our members, the head of organizations for all our members through both official letters and in our general assemblies, inciting them to be part of our project and give us a contact to their technical manager so that we can start working on the actual integration. Now, if you are a national mapping agency and your organization hasn't yet gotten that far as to get us the data yet, send me an email and I'll put you in contact with the relevant person for your data. So it will depend on if it is cadastral data or if it is topographic data. So depending on what type of data it is, it's a different production process and a different organization that leads on that process. So send me an email, let me know what it is, and I will make sure to get you in touch with the production manager of the relevant data set.
Thanks.
I hope that answered the question.
I think so. Then there is a question there are a couple of questions from Sheikh. And how do you collect data? So those data are provided by your members, the national geographic agencies.
Yeah, exactly. So we geographics ourselves. We're a membership organization. We don't have people out collecting data ourselves. In most countries, there's an official, well, all of the countries we are working with, there are official, one or several official mapping, cadastral, and land registry authorities. They collect the data. And what we do is we work for their interest. We work for the benefit of them and of Europe and what we do is we try to increase the use and the reuse of their data. So their data is collected nationally. It's extremely valuable, not only nationally, but also from a European perspective. And what we're trying to do is we're trying to make it easier to use it on a European level for the users that need cross-border data. Is there?
What about the updates? So you're aggregating data, that's one time, but are you planning to keep pace with the various updates?
So we update on an annual basis. It's and what's really special about our production system is that we do it together with the national data producers. We're just not an organization. We don't just scrape data from the national organizations and put it together and provide it as our own products. No, this is something that we are doing together with our members. So they are actively generalizing. They are actively working with us to make sure that the output has a quality that is as high as possible. I'm sorry, did that answer the question?
Yes. The last one, and then Victor has a couple of announcements. How is this data consumed through an API, or do you have download?
So for it depends on the data set. So all the data is accessible on mapsforeurope.org. All our open data are accessible there. Depending on the data set, it's accessible in different ways, via APIs and or via download. So for the large scale, high value topographic data set, right now it's available via WFS, WMS, and WMTS. And by the end of next month, you can also access it as GeoPackage, and you will be able to access it via a user specified area. So per country or per regional level 2 or the entire data set in itself. And then for the cadastral map is very different because the cadastral map we provided as a WMS and WMTS, not as download. And that's very important. In order to, we function as a gate to the cadastral members, so that you have the information on where to get Europe's cadastral data in one place. And then from there, it's very easy to go to the national geo portal to download the data from the national cadastral carrier. And that is yeah, that is, there are many reasons for that, and that we could do a whole new webinar about that, but that is the functioning right now.
Thanks, Victoria. Thanks a lot. Victor, you know that I'm always 15 minutes late. Usually it's at the beginning.
Emmanuel, just one thing, just if I can, most probably the 19th of November, the HVD cluster will organize a webinar on the aim of the cluster and the aim of all the project in order to show the result sheet. Sorry for interrupting you, but just to say that.
No, great. So 19th of November, if you can share with us the link.
Of course, when we organize everything, this is an idea, but we will keep you updated.
Yeah, great, super. Victor, as I said, I'm always 15 minutes late, but
no
usually
problem.
It's at the beginning. After 3 hours, I should be much more than 15 minutes late. So that's performance.
No problem. We've had a lot of interesting discussions, so it's no wonder that we ran a little bit over time. Thank you everyone for your active contribution. Thank you to all the speakers as well, and to all the attendees for all your questions. This really contributes to making a fruitful event. And I just wanted to highlight 2 action points to follow up on everything that we're discussing, because it's a shame to leave it all just in this event. But I just wanted to highlight the location ecosystem, which Emmanuel is the co-lead of, where this is a community where we have these types of discussions every month. We have regular meetings, and these are actually open to Gaia-X members and non-Gaia-X members. So anyone in this webinar today can attend. So if you are a Gaia-X member, then I would encourage you to look at the Gaia-X members platform, and there you can see the agenda for the upcoming meetings and any relevant documents. If you're not a Gaia-X member, then you can check out the Gaia-X website, where you will find further information and contact information for how to participate. So I just wanted to highlight that, as there's a key number of questions that are ongoing conversations, such as identifying those common standards. This is exactly what Gaia-X is doing through the labeling framework, and also extending it to more domain specific requirements. And lastly, I just wanted to highlight a save date for the Gaia-X Summit. So this will take place on the 14th and 15th of November in Helsinki, Finland, under the slogan of "Empowering Global Data Spaces, Shaping Tomorrow's Cloud Infrastructure." And this is our flagship event, our annual event, which will be a great place to meet people in person. So registrations for that open in September. And with that, we can end the webinar, and I'll wish you all a very good afternoon. Thank you very much for your participation.
Thank you all. Have a great
Thank you. Thank you.
So
Bye-bye.
much.
Thank you for
Bye.
this opportunity. Bye.